Back now, as we loaded the data, we're going to let's check the columns. Let's remove this so we get a little bit of space. Data dot info. Let's like see. Okay, to confirm that we have five columns, and it's very exciting that we don't have any null value here. All these values are consistent. 5572, 5572. So these columns, the unnamed three, unnamed two, unnamed four, they're not useful because they have too much null values. But this has none, so like it's ideal for us. So we don't need to go find any missing values because the values are completely found. The two variables we are interested in, the values are not null. So yeah, that's great for us. Now, the next step we're going to do is we're going to do some data engineering. We call it feature engineering. And basically, as we know what feature engineering is, kind of formatting your data, making it a little bit more presentable. The reason why I'm doing this feature engineering for this instance is that our v2 column, sorry, our v1 column, that means our target variable. You can see it's an object, and we know machine learning models accept only numerical values. So we need to format it into something, into a numerical value. And we all know that, wait, can I on the put on this next so we can see what I mean? We know that the v1 has ham, spam, ham, spam. Spam means the message is spam, then ham means the message is not spam. So that's what it means. But the machine learning model cannot understand this, so we need to convert this into a numerical correspondent. So for this, we'll categorize spam as one and categorize no spam or ham as zero. So that way, we know like we have narrowed it down to something very discrete. So let us write a function for this. Um, let's name it format. Format always have issues in naming my variables. Format v2, or say format the target variable. Format target variable, sorry, and we pass the variable here. And we say if var is equals to spam, then we return 1. Else if var is equals to ham, we return 0. Yeah, as we know, to apply a function to a data frame, that is a pandas data frame, we need to use the apply function. So we're going to call this data, it was v1. Sorry, I think I put some column if not run some error. Data v1 dot apply. Now when I copy this function that we created, okay, and then we run it. Yeah, so let us view what we have formatted. Okay, and let's do something. Let's see the distribution of the zeros and one, whether the zeros are so much than it, because this will affect the way we train our model. As we'll see as we're training our model, because when you're dealing with categorical um, target value, that is you're putting something discrete, which is classification purposes. Your target variable is a little bit most of the time it's always skewed to something else, skewed to more of ones in this case, or more of zeros. Right now, I mean, we have more data on spam than no spam, so we need to like check out so we can know what we do during our training during our training time. But we not like use it now, but we just see what is all about. Value counts, normalize. Okay, and there's no value, so there's no need of us doing that. Okay, we can see that 86% of our data are not spam, So it's only a few percentage that is spam. So we'll take this into account as we go on. Yeah, but for now we just keep it to ourselves. That the majority class is no spam. Okay, so in the next session we're going to do is tokenizing, and I'll explain this in a second. Tokenizing. Okay. Okay. I remembered when we did data processing, and we were trying to make prepare our data for machine learning model. So the columns that were not numerical, but we call them categorical columns that had some strange values and all of that were not like numerical. We had to do some um, one hot encoding that we said that we use the function method in pandas, which is pt.getDummies, if you can remember, and we kind of did one hot encoding to kind of format it so um, our data looks a little bit of looks like numerical by using zeros and one and all of that. So that's the same thing that happened in tokenizing in natural language processing. I will be calling it NLP in this session. So anytime I say that, you know that's what I meant. So for this for NLP, we will use a method called tokenize. And tokenize, what tokenizing does is it extracts all the words in a particular data set. We call it corpus. Yes. So we will extract all the particular words and create like a dictionary, a vocabulary of all the words, and then that whole vocabulary we now be used to categorize the each of the data points. Let's say for example, um we have five words in our vocabulary for the whole data set. Let's say we have orange, pawpaw, um just something else, orange, pawpaw, like guava, got the egg, and melon. And for our first data point in our first data point is, let's say our first data point does not have in each sentence, it doesn't have a pawpaw, it will be zero for pawpaw. But in that sentence, if he has watermelon, it will be one. So you know what I mean? It's just the same thing as that one hot a coding stuff. Yeah, but this one we use the words in all the words in the whole data set as a vocabulary, as a dictionary, and then use it to judge each of the data points based on what they have. So we will see this as we go on. I think if you don't really understand, you get to understand better when we start doing it. So we need to write a function to do our tokenizing, and then we have to create a dictionary in Python. let's call it vocabulary. And then what we do, like I say, we extract all the words in the data set, all the words on each data point. We want to extract all of them and add them to our vocabulary, our tokenized vocabulary. So we loop through the. I remember it was v2. V2 is v1 is our target variable. So it's v2 where we print to, and we now call the tokenized vocab dot append. Append is used to add something to a list. Sorry, this was not a dictionary. Sorry, it's a list. I made a mistake here. It's a list. So we use append to. So this what this split is going to do, split is going to split each of the words. So I'm saying we want to extract each word from each sentence. For example, if you say Obi has a watermelon, we will take Obi has a, like, separate. Don't add it to a vocabulary. Like, you go what I mean now. So we use this function to call items on split. We are splitting each words. If I should, if I want this, and I print it out, it's going to be very messy. But I'll just show you what it's doing. So let's run this. Hopefully, we don't get any error. So we'll call this tokenized vocab. So let us see what I'm talking about. Yeah, you can see it's going to be so messy. It's going to be so much. The words are going to be so much. But you can see you have already paid to go to. You can see each of them are being these are each words of each sentence are being splitted. You can see it. So yeah, I'll just clear this. So again, messy. Let's continue this in next session.